Hi, this video is about benzylic bromination. You probably remember from Chem 241 allylic bromination. This concept was covered in section 10.3 in the McMurray text. And the benzylic bromination is covered in section 16.9 in the McMurray text, if you're interested in reading about it and you have a McMurray text handy. The reaction involves the use of NBS. NBS has a structure shown here, and the acronym stands for N-bromosuccinimide. The reaction of NBS with an alkene gives an allylic bromine. Allylic means the bromine is on the next carbon over from the double bond. This reaction can be carried out either with light or the presence of peroxides to initiate the radical reaction. I'll talk a bit about the mechanism of the reaction. It happens through radical intermediates. This is the initiator that's typically used. It's called benzoyl peroxide. You might recognize that name. It is used in acne medicines. The first step in the reaction is the oxygen-oxygen bond breaks homolytically. You might remember this kind of bond breaking in Chem 241. When we showed these mechanisms, we use fishhook arrows to show that the two electrons don't go in the same direction. One electron goes to one oxygen and the other electron goes to the other oxygen. That leads us to two radicals. These radicals react with with NBS to give bromine radicals, and then the bromine radicals abstract a hydrogen atom from the benzylic position to give this benzylic radical, which is stabilized by resonance, a lot like the resonance structures that we saw with electrophilic aromatic substitution as well as nucleophilic aromatic substitution. This reaction happens at the benzylic position because that way the aromatic ring, the aromaticity is not destroyed. So here I have an example reaction with a couple of substituents on the aromatic ring. We have a propyl substituent and a T-butyl substituent, and it's going to react with NBS in the presence of peroxide, and the product that we get has the bromine in the benzylic position on the propyl substituent, and no bromine goes on the T-butyl substituent because it doesn't have any benzylic hydrogens. The benzylic hydrogen is needed for the reaction to go. In case you were wondering about the stereochemistry, this compound is racemic, so if we draw the reaction, the products out with the stereochemistry shown, we get a mixture of two enantiomers.